The steel beam calculator is mobile responsive, which means it will work well on all your devices: PC, Mac, tablet and smartphone. It's easy to use, but it does require some understanding of steel beams and structures. So in this video, we'll explain the information that's required for each section of the calculator. If you do get stuck while using the calculator, please call us and we can help. You'll find our phone number at the bottom of the Contact Us page. So let's get started. Section 1 of the calculator asks for your basic beam details. You first need to enter the effective span length of your beam. This is the distance from the centre of one end bearing to the centre of the other end bearing. For example, if the clear distance between supports is 3 metres and the beam has a minimum end bearing length of 0.1 metre at both ends, you would work out the effective span length like this: 3 metres plus half of 0.1 metre plus half of 0.1 metre equals 3.1 metres. Secondly, we need to know the shape and size of your steel beam. The calculator defaults to universal beams, but you can choose either universal columns or parallel flange channels instead. Universal beams and universal columns both have a distinctive eye shape, but while the depth and width are very similar in universal columns, the depth is always noticeably greater than the width in a universal beam. In contrast, parallel flange channels form a C-shape. Once you've chosen the right shape of beam, you don't need to worry about choosing an exact beam size until later. There's an auto beam select feature, so the calculator will suggest suitable beam sizes once you've completed all sections of the form. However, if you know your beam size and want to specify that now, set the auto beam select feature drop-down to no and find your beam dimensions in the relevant drop-down menu. For the next section, you need to know what type of load your beam will be supporting. A uniformly distributed load is where the load is evenly distributed across the full length of the beam. A roof or floor would fall into this category. A partial uniformly distributed load is where the load is evenly distributed across part of the beam. And a point load is where there are localized loads at certain points along the beam, such as when a steel beam is required to support another steel beam. If you choose either uniformly distributed load or partial uniformly distributed load, you can select the loading details from the drop-down menu, and then enter the width or height of the load. Use Other if you can't see an option that describes the nature of your load. You don't need to add the weight of the steel beam itself, the calculator automatically allows for this. For details on how to calculate the load widths, go to our guide page and then click on the link to the diagrams showing how to calculate load widths. There is also further information on the examples page. We also have a list of standard loads for commonly used items such as clay tiles and rafters. You can add multiple loading details to each type, for example more roofs, floors, walls and so on, or you can add another load type. For point loads, you will need to enter the dimension between the point load and the end of the beam, as well as its permanent and variable load. Finally, give this point load a name. Permanent loads are usually things that do not change, such as the weight of a wall or the floor, whereas variable loads change, such as people or furniture. If you need to work out the point load from a beam that is going to be supported by another beam, we've created a guide to help you. See our guide page and follow the relevant link. The next section is safety factors, and the calculator defaults to our recommended allowances. So unless you want to change these, you don't need to enter anything in this section. However, it is important to understand what this section is for. In order to ensure your steel beam is really safe, it needs to be capable of withstanding a greater load than you specify. The default safety factor for variable loads is 1.5. This means that the calculator will multiply all variable loads by 1.5. For permanent loads, the safety factor is 1.35, and so all permanent loads you enter will be multiplied by this figure. The fourth section of the calculator is about how your beam will be restrained. You need to know if the beam is going to be fully restrained along its length. Usually the answer is no. It is only classed as fully restrained if it meets the requirements in the SCI publication P360. For example, if the beam is cast into a concrete floor. If your beam isn't going to be fully restrained, you'll need to know the length between its lateral restraints. This is usually the same as the beam span length. However, if another beam is fixed at right angles to the beam along its length, this will provide lateral restraint. In this case, you should measure the greatest distance between lateral restraints and enter these details. If you need more guidance on restraints, please call us. The final section is for deflection limits. A deflection limit is the maximum amount you allow the beam to sag. You can set a limit for how much it can sag under variable loads and under permanent loads. Our calculator defaults to the recommended limits, but you may need to change these. For example, if you are using the beam to span above bifold doors, you may need to set a variable load deflection limit that's lower than the default. Or if the beam is going to be used as a structural ridge beam, the variable load deflection should not normally exceed 10 mm. We recommend that the total variable and permanent load deflection limit doesn't exceed the span length divided by 200. However, some engineers recommend a lower limit of 250. And that's all the information we need. Now you just have to press the Run Calculation button. If you left the Auto Beam Select feature drop-down set to Yes, the calculator will now show you a list of suitable beam sizes for your project. Choose one from the list and your PDF report will appear within seconds. We hope this video has given you an insight into how the steel beam calculator works and what you need to know before using it. Thanks for watching.